Good morning, everyone. Today we're going to start our discussion formally on multiple linear regression, which is our first lesson. And this will cover perhaps uh, maybe 6, 7 weeks. The bulk of our discussion in this subject is multiple linear regression because there are many facets about it. So we discussed last time that linear regression is all about uh, it's a technique, statistical technique, where you want to uh, uh, describe or define the relationship between your variable of interest, which is your which is your response variable or outcome variable or your dependent variable, using explanatory variables or independent variables. So the goal is to be able to establish a mathematical relationship between the two. By doing so, you'll be able to explain as I said, the variable of interest, the dependent variable, making use of your independent variables. Okay. Another main objective is for you to be able to forecast your dependent variable. Given the values of your independent variable, you will be able to forecast the value of your dependent variable. Now, the method used for multiple linear regression, which I'll discuss in greater detail as we go along, is what we call the ordinary least squares. Okay, least here means the smallest value of your squares. Now, what could be the meaning of squares here? Anyone? I think we partially discussed this, but I did not introduce to you the formal name, ordinary least squares, OLS. Okay, it's ordinary, as I said here, because it involves only one explanatory variable. You're only dealing with one independent variable, the one that explains your dependent variable. So ordinary. Okay, least squares. What do you think is least here? Excuse me, class. What do you think is least? I think I discussed this with you last time. What is least here, class, is that we want to create a model so that the residuals, the difference between your actual value and your predicted value, okay, the sum of the squares of the difference between your actual value and your predicted value is at a minimum. Okay, I'll describe this in greater detail as we go along. Okay, so this is your LaTeX, and we said that the equation for a multiple linear regression is such. Your dependent variable is explained by, okay, so this is your independent variable 1, independent variable 2, okay, independent variable 3, okay. Sorry, actually uh, I is no longer needed here. No? Okay, so independent variable 1, 2, 3, up to n, okay, and you establish an equality between them by adding this. This one is your, the value that you get here from beta null, this expression is your predicted value, okay? This is your actual value, and the difference between your actual value and your predicted value is a certain value, which is your residual. Okay, so if I remove the residual here, then this is transformed into a y hat. Okay, so if I remove residuals here, for example, let me do that. Yi, okay, and let me see, hat. Yeah. Let me check if this is the correct. Yan, hat, no? Kaso mali yung syntax ko. Dapat wala tong ano. I don't usually memorize LaTeX, no? Yan, class, no? So hat, y sub I, and then I'm going to delete this one, epsilon. Okay, maybe I should just rewrite it. I'll just okay, and let me just create a new one. I'll copy this, Control C. Okay. So let me put here hat. And then I remove this. All right, so take a look at this class. As I was saying, this value here, your beta null, beta 1 times x1, beta 2 times x2, etc., is your predicted value. Okay, if we have determined the intercept, the value of your the coefficient beta 1, beta 2, etc., okay, and substitute the values for a given value of y, there are the values of your x1, x2, x3, x sub n. If we substitute, okay, if we multiply beta 1 to x1, etc., then we get a value which is your predicted value, and that is your y hat. Okay, that's your y hat. Now, as compared to this one, okay, your y sub 1, okay, it's equal to, so this is your actual value is equal to your predicted value plus a certain error term. Okay, because usually they will not be equal, so you add a certain value here to make them equal. Okay, and then we define here what's your dependent variable, dependent variable y, your explanatory variables, okay, and then this is your y-intercept, and the coefficient or the slope coefficient for each of the explanatory variable, and then your error term. Okay, let me pause for a while, and I'd like to you to comment, class. So far, okay lang ba? Am I going too fast? Or does this remain a mystery to you, itong equation na to? So far, clear ba, class? Okay, thank you. Enrique, thank you. How about the others? Please feel free to ask questions, class. No? So, kung medyo malabo yung pag-explain ko, kasi of course, hindi man laging klaro yung pag-explain ko. So, if you have any questions about the topic being discussed, please feel free to raise your hand or to give your comment about your questions. Okay, only two, class. Only two comments. May I know from the others, please? Okay, thank you. All right. So as we said, class, the main goal of multiple linear regression is for us to be able to establish a relationship. This is the relationship, class. Your dependent variable is a function of your independent variables. Okay. So these are the slope coefficients, or this tells us about the marginal effect of your x1 on y1. Okay. Now, when we do multiple linear regression, we have to be aware of the assumptions. When you do OLS, ordinary least squares, there are certain assumptions that come with the model. So let's first take a look at let's go through the assumptions one by one first quickly, and then we go to an example. Okay, so number one assumption, there should be a linear relationship between the data. There should be a linear relationship between y sub y and your x. Okay, we would want your dependent variable to be highly correlated with your independent variable. But take note, we don't want the independent variables to be highly correlated or collinear with the other independent variables. So I hope that's clear. We want the independent variable to be correlated with the dependent variable, but not with each other. We don't want your x sub 1, your independent variable 1, to be highly correlated with your independent variable 2. Okay, we'll discuss this more in greater detail. Number 2 is that there should be linearity of the parameters. Okay, so as I stated here, yung assumption 1 natin requires that the dependent variable should be collinear, if possible, highly correlated with your independent variable. Okay. However, assumption 2 requires that there should be linearity in the parameters. What do you mean by this? What do you mean by linearity in the parameters? Okay. What we mean is that your coefficients, your betas, which is this one class. Saan yan? Ito. Okay. So if you take a look at this, okay, equation 1, lalabas yung equation 1, no? And then this double line means this double forward slash means that it will start on the next line. Ito. So this is your y sub I underscore yung ano, no? Yung I. Okay, so this is the equation. And take note, class, your beta 1, okay, beta 1, so this is your subscript siya. And then, ito naman yung superscript. Okay, so this beta 1 squared. All right? So what does this mean? Yung linearity sa number 1 class, dapat yung dependent variable should be, your dependent variable should be linearly related to your independent variables. Okay? It means hindi dapat quadratic, hindi dapat ang relation is a certain may power, no? Dapat linear lang. Tapos yung number 2 naman, dapat yung mga parameters natin dapat linear. So dito, class, hindi pa pwede ito. This cannot be, no? Kaya hindi rin pa pwede naka-square root siya, hindi rin pa pwede naka-log. Okay? So dapat linear lang siya, beta lang siya. Okay? So, pero class, pwede ito. If I run this, ito pwede ito. No? Take a look at this class. Your y sub I is equal to beta null plus beta 1 times x squared. Beta 2 times log of x. Beta n times square root of 1 over x sub n. Pwede yun. Okay? Pwede yun. That does not violate linearity. Okay? Pero yung coefficient mismo, ito, beta 1 squared, square root of beta, 1 over beta, hindi pa pwede yun. Okay? So that's what we mean by the second assumption. Linearity of the parameters. Okay? So let me pause for a while. Any questions so far about linearity? Linearity in the relationship between your dependent and independent, and also linearity as far as the parameters is concerned. Any questions about that? Clear naman so far, class? Okay. Okay, good. All right. You have this in your notes, right? Hanggang dito sa number, meron tayong number 2, right? Tama, class? I already shared that with you. Okay, next. Thank you. Okay, what's the third assumption? The third assumption, class, is was also discussed last time. It has something to do with the homogeneity of your residuals. Okay, the variance of your residuals should be homogeneous. It should be homoscedastic. Okay, commonly spread out, and it should not be heteroscedastic. Okay, which means, class, that when we perform our regression model, and then we were able to generate our model. When we say generate, you're able to determine what's your intercept, beta null, what's your beta 1, beta 2, beta 3. We're able to determine the values of the parameters. It does not end there, class. Our model does not end there. We will have to diagnose our model and check to see the uh, whether there are violations of the assumptions. So for example, itong homogeneity of residuals variance, it means that when we plot our residuals, which we're going to do, could you resend equation 2 and the third assumption? Okay, sige. Equation 2. Okay, I'll resend equation 2, class. This one. Okay, I'll start from here. Okay, let me, okay, Control C. I'll chat this so that we have a record of the chat. I cannot chat long lines. Zoom does not accept it. No? Okay. So that one. Okay, and then also, I'll also send the next one, assumption 2. So Control C. I'll chat this. Okay. All right. So if you don't have this, okay, so it does not accept because you cannot, sana pwede dito. You cannot chat long messages in Zoom. Yan, okay. So I chatted, class, I copied to the chat box assumption number 3, homogeneity of residuals variance. Okay, so let me just go to Word. I wonder why. Okay, so for example, class, if we plot, bakit ayaw? Okay, so if we plot the residuals, for example, let me call it E, okay, and this is your, let's say, X, one of your variables. Okay, I'm supposing that we're doing an OLS, no? Ordinary least squares, which means that there's only one independent variable, X1. Okay, if we plot the residuals with respect to let's say, an independent variable, if the plot behaves this way, this is what we said a while ago, the last time, if there seems to be a trend, okay, an increasing value in your residuals as your X increases, okay, then this is what we call non-constant yung variance siya, non-constant variance. Because if we, let's say, draw a line here, okay, your residuals should be behaving, should be randomly generated across this band. So dapat wala siyang, it should not have a trend. Okay, neither should it have an fanning out. Okay, your residuals can behave this way. So you can see that across, for a bigger value of X, this is your X, this is your residuals, your variance is increasing. Dito, yung variance natin, ito lang. Tapos as we increase X, the variance, the residuals behave in such a way that the variance increases. So ito yung sinasabi natin class na heteroscedastic. Heteroscedastic. So if our error terms display a heteroscedastic distribution, then we say that our model violates the assumption of classical linear regression model as regards homogeneity of residuals. Okay, number 4 class is that the explanatory variables are not collinear. This is what I mentioned a while ago. It's important that the independent variable and the independent variable should be collinear. Okay, because there's no point class in, for example, if we plotted your, so this is your X, this is your Y. If we plot X and Y and it behaves this way, so parabolic, no? Parabolic, then we cannot say that there's linear dependence between Y and X. Kasi hindi naman linear to eh. In fact, pag minodel natin to, pag nag-create tayo ng linear model, it will look like this. Okay, so this will generate lots and lots of residuals. Okay, kasi kunyari, here, this is your actual point, this is your Y sub I, this is your, okay, dito sa line na to class, this is your X, no? This is your X. Okay. So this is your predicted value. Let's call this Y sub I hat. This is your predicted value. So the difference between this one, this distance, which is the distance between your actual value and your predicted value, is your residual. Okay? Yun yung mali, yung error, di ba? So for this one, class, this is your actual value. This is your predicted value. If you drop a line here, this is another residual. Okay? So what happens is that you will be able to generate a model. However, it's not really it will not be a good measure. It will not be a good fit. Kasi magiging malaki yung residuals natin. Okay? So more on that as we go along. So that's what happens, class, when your Y and X are not collinear. Here, they're quadratic. Okay, so we want the Y and X to be collinear. But we don't want the x's to be collinear. For example, in a multiple linear regression, x1, x2, let's say their correlation is, let's say, there are x1, x2, correlation is equal to 0.9. Okay, that's high correlation, 0.9. Now, the problem with this is that it will be quite difficult to determine what percent of the variation of y is being explained by x1 or x2. Okay, why is that so? Kasi very highly correlated sila, di ba? If they're highly correlated, then it might be difficult to determine which of them explains y more. Kasi nga, halos pareho lang sila eh. They're very correlated. So it's difficult for us to really disaggregate ano yung percent ng variation ni y ang dinidescribe ni x1, ano naman yung variation ng variability ni y na dinidescribe ni x2. So that's the reason why we do not one assumption of classical linear regression model is that the explanatory variables should be not linear. Okay? And this phenomena is called multicollinearity. If the independent variables are highly correlated, then multicollinear sila. Okay? Predictors are not too highly correlated with one another. If they're highly correlated, then we will have what we call multicollinearity. Highly correlated sila. And sabi ko nga dito, this is a problem because it can be hard to disentangle which of them explains any shared variance with your x, with your y, with your outcome variable. Okay, also it suggests that the two variables may actually represent the same underlying factor. Okay, all right, then number 5, you have independence of residual error terms. Now, ibig sabihin yung error mo for value ng error between the difference between your predicted value and your actual value, data point 1, okay, should not be correlated or should not be dependent on observation 2 or observation 3. Now, this is more a problem of time series. Okay, this is more a problem of time series rather than cross-sectional, which brings me, okay, there are 3 main data types that we can use. Number 1 is you have your cross-sectional data. I don't think I discussed this with you last time. I was able to discuss this in the other section. Cross-sectional data, time series data, and panel data. Okay, anong difference ng tatlong to? What's the difference between cross-sectional, time series data, and panel data? Anyone? What is the difference between cross-sectional data, time series data, and panel data? Any volunteer? Let me start with cross-sectional. Lolo ko tong ano ko ha. Cross-sectional class. And then we have time series. And then we have panel data. Anyone? What's the difference? Any volunteer? Yes. Okay. Joseph, please.
Hello, sir. Am I audible po?
Yes. Yes.
Cross-sectional po, I think this is like many data, like for example, data from several persons through a certain period of time. So marami po siyang time. While time series, like ayun po, like may period of time siya. Tapos panel data, it's like more data lang, like for the example kanina, like more people, tapos like at one point in time lang.
Okay,
I
thank you. Thank you, Joseph, no? Thank you also, Glenn. Sabi ni Glenn, sa cross-sectional data, mukhang pareho kayong sinabi, no? Sabi ni Glenn, cross-sectional, many subjects, but one time frame. Okay, that's correct, no? So, pag cross-sectional data class, if you have cross-sectional data, if you take a look at the units or the unit of the unit, what's the term for this? The unit being considered, the number of units being considered. So pag cross-sectional, as far as the number of units or individuals, okay, you have several. And as far as the point in time frame, point in time, okay, it's equal to one point in time. So several units, point in time one. Okay, let me explain. Let me give an example. Okay, so suppose class you're looking at macroeconomic data, kunyari GNP, GDP, money supply, employment rate, death rate, population, etc. Okay. And then you take a look at units, no? Sabihin natin ASEAN o ASEAN 5, sabihin natin Philippines. Okay? And then Singapore. And then Thailand, Malaysia, Indonesia. Okay? ASEAN 5 na lang, no? Okay? And then year 2022, 2022, 2022, 2022, 2022. O dagdagan pa natin, sabihin natin kasama US, kasama China, kasama Australia, kasama UK, kasama France, etc. So what type of data is this? This is called cross-sectional data. Bakit? Kasi you have several units. No? Ito yung mga units natin. So you're focusing on these individuals, Philippines, Singapore, Thailand. Okay, you're getting the GNP, GDP, etc. However, it's only one point in time. 2022 lang. Okay? 2022 lang siya. So that's a cross-sectional data. On the other hand, a time series data class, ang time series, sa number of units class, number of units, ito equal to 1. Tapos, points in time ito is several. Baliktad siya. No? Several. Okay, let's take a look at our example. Let's go back to our example. So time series siya kapag you only focus on the Philippines. So ang unit natin, the individual that we're focusing on is Philippines. Ano gusto mo tingnan sa Philippines? Well, the same, no? GNP, GDP, money supply, etc. Employment rate, death rate. Okay. So you have those same variables, but yung year natin is, okay, so let's suppose from 1970 hanggang 2022. Okay. So what type of data is this? This is what we call a time series data. Kasi yung unit na tinitingnan natin, isa lang, no? Philippines lang. Ano yung time frame? Ang dami, from 1970 to 2023. That's what we call a time series. So magkaiba klase yung structure ng isang cross-sectional data at saka time series. Magkaiba. And they call for different types of analysis. Kaya nga itong subject na to, no, FINARTS, applied regression usually for cross-sectional data and time series. So iba yung methodology na gagamitin natin pag nag-plot tayo ng time series. And lastly class, yung panel data. Okay, ano naman yung difference ng panel data? So sa panel data, number of units, so it's a combination of your cross-sectional. So several to, and points in time is several din. Okay? So it's like combining your cross-sectional data and time series data. All right? So going back to our example, So if we combine itong several countries ito, no? Okay? And then we take data from 1970 to 2022. So ano mangyayari doon? You have several units and several points in time. So that's what we call a panel data. Okay? Of course, in terms of analysis, pinakamagandang i-analyze, mas rich and mas robust yung magiging output natin is panel data. Okay? And we will have a session where we will study how to conduct panel data regression. Okay? So iba yung method pag cross-sectional, iba yung method pag time series data, iba din yung method pag panel data. Okay? All right. Any questions so far, class? Paki-chat naman please kung clear so far yung ano natin, yung discussion natin. So far clear ba yung distinction between cross-sectional data, time series data, at saka panel data? Okay, good. Good. Of course, of the three, mas pinaka-rich ang makukuha sa information pag panel data. Okay? And by the way, class, sa panel data, we have two types, no? We have the balanced panel data and the unbalanced. Ano yung balanced at saka unbalanced? Yung balanced class, suppose we have this, ito, no? Ito na lang, yung ASEAN, 1, 2, 3, 4, 5, ASEAN 5. Okay? So you have from 1970, we get this data, okay, hanggang 2023 o 2022 o 2023, tapos na pala. Until 2023. Tapos, yung Philippines, Singapore, Thailand, Malaysia, Indonesia, from 1970 hanggang 2023, kasama sila. Hindi nagbago yung units. Okay, every year kasama sila. 1970, meron silang 5. 1971, meron silang 5. Hanggang 2023, kasama silang 5. That's what you call a balanced panel data. Okay. If in the case of, in the change of the period class 1970, 71, 72, may naaalis sa data set natin na units, tapos may nadadagdag na iba. Okay? Kunyari, si US, no? Hindi siya kasama noong 1970. Pero noong 1980, pumasok siya. No? Si China, kunyari, previously hindi siya kasama sa data natin. Pero ng year 2000, sumama siya, nakasama na siya sa data, then that's what we call an unbalanced panel data. Okay? So magkaiba yung class, no? Yung balance, strictly, yung at the start of the period hanggang at the end of the period, hindi nagbago yung ano natin, yung mga yung sa units natin, balanced yun. Pag nagbabago-bago siya over the periods, then that's what we call unbalanced panel data. Okay, so let's go back here. Now, I wanted to point that out, class, kasi yung independence of residuals, residual error terms, this will matter more for time series and panel data. Why is that so, class? Why is that so? Bakit kaya relevant yung independence ng residual terms sa panel series, time series data at saka panel data, and not on the cross-sectional data? What could be the reason for that? Okay, the answer lies in, class, how the data is arranged. Yung time series, 1970, 1971, 1972, yung data na yan, class, hindi pwedeng i-jumble-jumble yan. Hindi pwedeng, I feel that, I think it's better to put 2023 first, and then next follows 2017, and then 1998. Okay, because if you can change the order of your data, then the position of the residuals will change, right? In time series, 1970 will always follow 1971, right? So the order of the residuals will not change. So you can now establish if there's a relationship between the residual during 1970 and 71 and 72 and 73, etc. Because the arrangement is fixed. You cannot change it. On the other hand, for cross-sectional data, do you think the result will change if I put it alphabetically? Do you think the model values parameters will change if I put Philippines first and then USA and then Canada, or I put Malaysia first, Singapore, etc.? No. The order is inconsequential class. If you arrange your cross-sectional data in such a way that it's sorted alphabetically, A to Z or Z to A, or randomly arranged, okay, it does not matter. Okay, right? The results will be the same. However, the independence of the residuals will now be different because for example, I put Philippines first, and then USA, and then Canada. What will now happen is that the residual for a particular observation in Philippines will be next to that of the USA, and USA will be next to that of Canada. All right. So if we're trying to establish the independence of the residuals, dependent by residual of US to the Philippines. Okay. What happens if it was changed, right? If it was changed, so Philippines now comes next to Singapore, etc. Okay. Do you get what I mean, class? Yung independence of the residuals. Okay. So the order there matters. So okay, let me open another one. Okay. So I was saying, class, pag time series kasi, 1970, 71, 72, etc. So if we plot the residuals E, for example, this is the amount, for example, this is the amount of residuals, etc. The order matters. So ang question dito, is the residual in 1970 independent or related to that of 71? Is the residual of 71 related to that of 72? That's what we mean by independence. Now, that does not matter in a cross-sectional data. Kasi pwede nating pagpalit-palit yung yung order ng data natin, no? All right? So I hope that's clear, class. May I have your feedback, class, if the discussion here of the independence of the residual terms is clear to you? Dali Let me just... Okay. Kindly chat, please, if clear yung importance ng independence of residuals. However, it's more important for a time series data and a panel data. Okay, thank you. And lastly, class, the residual should be normally distributed. Now take note, we're looking at this sa huli, class, kasi of the assumptions, this is the least important, yung normality of residuals. Okay, kasi if you have a large data set, okay, the normality of the residuals, the distribution, kung normally distributed ba siya, it becomes irrelevant. Okay, there's a law in statistics. Okay, I don't know if you have if you recall that. Ano yung principle sa stat class about normality, class? Do you recall that? Okay. No one? Okay, sige. I'll let you recall that, class, about yung normality, no? Okay. Meron pang additional class dito, no? Which we're going to discuss also. Another important assumption is the presence of outliers. What does that mean? What does that mean, class? Pag may data point na medyo malayo siya, no, to the rest, that can affect your model. Okay, so we're going to discuss that as part of our diagnostics. We're going to see if there are data points that are outliers. Okay, and we should be very careful about that. Now, it's possible that was there a mistake in the recording? Kasi kunyari, you were talking about, let's say, we were looking at the ano kayang particular ano? Let's say wala akong maisip ngayon ano. Kunyari, it escapes my mind. No? Kunyari, you're talking of the price of a certain commodity, prices of commodities. Tapos, ang range siya, let's say from 100 to 1,000. Tapos biglang merong isang commodity na andun 1 million yung price. So parang ang layo yata niya, no? Kasi yung iba class, 100 to, ranging from 100 to, let's say, 1,000 lang. Tapos may biglang 1 million yung price. So that can affect the model greatly. No? So diyan papasok class yung relative, yung related terms like leverage points, discuss natin to, and influential data points. Okay, as far as outliers is concerned. Now, that's a good question, Glenn. No? Ang question dito ni Glenn, would it generate a bias if we remove outliers? That's a very good question. Now, that's the last thing that we want to do. No? That's the last thing that we want to do. Just remove the outliers. You have to first investigate. Okay? You have to first investigate. Bakit kaya ganun siya? Was there a wrong recording? Baka nagkamali lang. Baka yung 1 million na yon, dapat pala 500 lang yon. Okay? So, hindi natin talaga tinatanggal kagad, no? Unless we come up with an investigation. If it was due to a wrong recording, of course, babaguhin, aayusin. Pero kung talagang ano yun, kung talagang ganun talaga yung data point na yon, then ang question doon, should you now remove that? So that's a matter for the one modeling to decide. Or should you now come up with a model without that data point, and then come up with another model with that data point? Okay, so these are things that the modeler should address depending on the objective niya dun sa ano yan, sa research niya. But thank you, Glenn. That's a very good question. Ngayon meron namang may mga issues din later on na i-discuss natin. Okay? What if there's no way for us, ito naman yung mga missing values din. Okay? Because sometimes it's possible that there are missing values and it's no longer we can no longer, let's say, get that data. So later on din pag-aaralan natin class, anong gagawin natin kung may missing data? Okay? Okay, there are techniques for that if there are missing data. Okay? So thank you for that question, Glenn. Any other question about this? Okay, so let me just share with you these references. Okay, it's a chat ko class for you may wish to. By the way, Glenn, did I answer your question? Glenn?
Yes,
Okay,
sir. Yes, sir.
okay, thank you. All right. So, balikan natin to class, no? Balikan natin tong let's go back here to the assumptions. All right. Number one, let's take a look at the linearity of the data. Mag-discuss lang tayo ng konti dito, no? We will give an example. Okay, so mag-generate tayo ng mag-simulate tayo ng data. Tingnan natin class ano mangyayari if there's if the relationship between y and your x is not linear. Okay. So mag-simulate tayo ng data class. Okay. And then let's see what happens if we have an instance where your x and your y your x and y are not linearly related. Okay. So there's a function in in R called set.seed. Okay, kasi magsa-simulate tayo dito ng data, no? Mag-generate tayo ng random numbers. So para pare-pareho yung data natin, there's a function called set.seed. Okay, so this is a random number generator seed to make our random numbers the same. Okay, so let's just set a seed, just put any number there, gamitin lang natin 1, 2, 3. So pag ginamit natin to class, whatever random number we're going to generate, pare-pareho tayo. Okay, otherwise, pag hindi natin gamitin yan, if we don't use that, then we're not going to generate the same numbers. Okay, the first function that we're going to use is gamitin natin muna yung run if. No? So there's this function called run if. Okay. Kaka-problema yata yung ano ko. Okay, so sa console na lang, question mark, ibig sabihin parang help yan, no? Help function. Nagkaka-internal server error ako. Okay. Isa pa nga. Pero package to eh. In your case, were you able to generate class? Nag-generate ba yung help nito ng run if class? Type ko rin dito. Nag-internal server error ako. Sorry class. No? All right. May I Raul, favor please. Stop share ako. Can you kindly share your screen para discuss ko lang briefly yung ano yung run if na function. Okay, thank you. All right. So maraming run if diyan ano. Sa ano nga dito sa help may go to the window files pane. Doon sa upper right may question mark, di ba? May icon, may ito to sa baba pa. Sa baba may magnifying glass na icon, search icon. Up ka pa, up yung cursor mo. Yan diyan. I-type mo nga run if. I-run mo siya. Yan. Okay. So that's what we need, no? All right. So yung run if class is a function. It comes from stats package. Okay? Stats package siya. And we don't need to install this kasi it comes pre-packaged with R. So yan kasi iba yan, ano? D uniform distribution, P, Q, quantile, at saka R, no? Random. So the uniform distribution class, these functions provide information about the uniform distribution. Okay? So ano ba yung uniform distribution class? It's different from the normal distribution. Okay, baba ka, tingnan yung syntax ng run if, ano? Run if. Go up please. Yan, tingnan yung class. Usage. Okay? Could you point your cursor to that, please? Yan, run if. Tingnan nyo. Sige, baba. Sa run if, yan. Run if, you have ilan yung ipapa-generate natin na number, tapos anong minimum number, tapos anong maximum number. Okay? So we can use this in order to generate several numbers, no? Kunyari, gusto natin mag-generate CR ng iba't ibang numbers. Ilan? Kunyari, 100. Tapos ang minimum niya, ganitong number. Ang maximum niya, ganitong number. Okay, thank you. Sino to? Gab. Thank you. All right, share screen ulit ako ha. Okay, so let's use that. Okay, dito sa linearity. So set that seed class, tapos let's create an object called X. Okay, I'll create an object, X. Okay, so if you, I hope you have watched the video on data and data structures and how to create an object in R. So alt minus class. Alt minus is the shortcut for command minus yata or option minus sa Mac. I think option minus for creating an object, no? So X, and then this is your this is called your assignment operator. So gamitin natin class si run if. So run if there. Mag-generate tayo ng kahit 50 numbers, 50. Okay, ang minimum natin, gawin natin minimum.
Sir, hindi po kayo nag-share screen.
Oh, sorry. Okay. So as I said, nag-set that seed tayo, no? So that we generate the same numbers. X, I'm creating this object X and I'm assigning it this one class, assignment operator to, di ba? So instead of typing less than and then dash, you can just press alt minus, okay, or option minus. Okay, minimum natin class, sabihin natin, litan lang natin, -5, para hindi masyadong wide yung ano natin. Maximum is equal to 5. Okay, so what R will do, this is uniform distribution, no? What R will do is that it will create 50 numbers from -5 up to 5, and then halos equal lang ano nila yung distribution nila. Ganun yung uniform distribution kasi, no? Halos equal lang yung distribution nila. Okay, so that will be our X. All right, and then let's create another object called, let's create U. No? This will be for random numbers, no? Alt minus ulit. And then let's just use an object called a function called rnorm. All right? Si rnorm naman ng class, mag-create siya ng randomly generated numbers din na may normal distribution. So ang syntax niya class, rnorm, and then ang default niya, ang mean is 0 and standard deviation is equal to 1. Yung sabi ng function, di ba? Let, no? Ayan. If you can see here the IntelliSense, rnorm, and mean is equal to 0, standard deviation is equal to 1. So if I just put here, so mag-create din tayo ng 50, no? Para pareho yung X natin at saka ano, X at saka U. Now, if I create 50 random numbers, tapos yan lang, ang ibig sabihin niyan class, yung mean niyan, yung mean ng object U is 0, approximately 0, and the standard deviation is approximately 1. Okay, sandali subukan lang natin class. If I run this, okay, i-run muna natin tong set.seed. Hindi, sige, i-run na natin lahat to, no? Para ma-run na natin si X at saka si U. I'm going to run this. Run. Okay, so just to test class, I'm going to get the mean of U and the standard deviation of U. Okay, let's check kung mean ba niya 0 at standard deviation 1. All right, mean is 0.05. Medyo hindi siya masyadong malapit sa 0, no? It's because ang liit lang ng ano natin ng sample size. Pero paglakihan natin yan, kunyari try to experiment, gawin yung 1,000 yan o 10,000 o 100,000. You'll see that the mean is practically 0, no? And the standard deviation is practically 1. The reason why it's not as close as possible to 0 is because our size is very small. So 50 lang. So baguhin natin to class. Saan na tayo? Let's put para pare-pareho tayo. Lagyan natin baguhin natin to. Kahit mean is equal to 0, standard deviation gawin nating default na pala, no? Okay, if I put here SD is equal to 1, pareho lang yung class, no? It will not matter kasi ang default na standard deviation is equal to 1. So putting their mean is equal to 0 and SD is equal to 1, it's just the same as not putting it here. Kasi default yung mean is equal to 0 and standard deviation is equal to 1. Okay, I hope you got it, class. Okay, so i-run natin ulit to just for the sake of running it. Okay. Sandali, class, ha. Let me, kasi magkakaiba tayo kasi I was doing some, let me clean this. Alright, cleaning ko muna yung environment ko para pag rinan ko to, okay, I can now see, okay. So rinan ko to, class, you notice that it created this object X and this object U. What type of objects are these, class? What type of objects? Yan ang mga tanong ko sa exam, class, ha, kasi it's related to the video that I was asking you to watch. Anong object to? What data structure does this have? Is this, class? It's a variable. Okay. Please share your answer to everyone. What type of variable is this, class? What type of data? What's the structure of this data? Anyone, please? Pag hindi niyo pa napanood, class, yung yung video, dapat panoodin niyo yan. It's a numeric. Numeric siya, pero hindi naman type of data yung numeric, eh. Either character, type of data yan. Pero anong type ng structure? That was my question. Thank you, Glenn. But the question is, what type of data structure? It's a double, hindi rin, eh. Ang double at saka yung numeric, Glenn, pareho lang yun, no? It's a, the answer, class, is data structure ang tinatanong ko. Ang data structure, class, can be a list, can be a matrix, can be an array, can be a data frame. Okay? So it's a vector, class. Vector ang tawag dyan. Okay. It's a vector. Nagkakaroon ako ng error sa file out. Mamaya, tinan ko yan. It's a vector class, no? It's a vector class is a type of data structure where all the elements are the same. So ito lahat, no? Panay siya, panay quantitative, panay numeric siya. Ito ding X, panay numeric. Kasi pwede ang isang object, pwedeng numeric at saka character, eh. So pag combination kunyari ng 2, C, false or true, that's what we call a list na. List na siya, L-I-S-T. So kindly review, please, yung data structures because that will be the subject of our first quiz. All right. What do you notice about my U and X, class? So if I print ko yung head ko, head X. So this will print the. All right. So what do you notice, class? Head ng X ko, negative 2.12, 2.8. In fact, class, if I do the summary of X, diba? Yan, class. Minimum is negative 4.75. Maximum is 4.9. Okay? So medyo equally spaced sila, no? Kasi uniform distribution to, eh. So yung negative at saka yung minimum at saka maximum almost 5. Kasi dinefine natin minimum is negative 5 and maximum is 5. Again, not quite close to the minimum maximum because maliit lang yung sample size natin. Pag ginawa ko tong, for example, 10,000, linakihan ko siya, no? And then you get the summary, most probably, class, very, very close to negative 5 yan, at saka positive 5. Okay, Clear so far, class? Clear so far? Hindi nyo pa nasagot class yung tanong ko. How does my x value compare with yours? By the way, the head function, okay, for those who don't know yet, the head function will give us the first 6 values of your object. We can define this to be, for example, 10. Head ng x, yung first 10 values yan. Control Enter, yan. Ibibigay sa atin yung first 10 values. Yeah, thank you, Raul. No? So I hope we got the same values. Class? Same values? Same values ba lahat, class? Paki-chat naman. Okay, thank you. How did we get the same values, class? Kasi nag-set that seed tayo. Okay? Set that seed tayo. You can experiment, class. I-comment natin tong set that seed. Okay? And then I'm going to rerun this. Okay? X, run if, and then head X. Control Enter. Okay, tingnan nyo, class, na iba na. No? Na iba na. So if we were running using this run if, and then we don't use the set that seed, we will have different values. Okay, magkakaiba-ibang values tayo. So importante itong set that seed class as a random number generator so that we have the same. All right, even with you class, it's the same. All right, and then let's now create an object called y. Alt minus. Let's define y to be x, capital X dapat, x squared plus, let's say, 3x plus a random number. Okay, take a look at that, class. So we're creating an object called, sorry, 3 times x. Okay. All right. So x squared plus 3x plus u. Yung u natin, yung random numbers, no? Okay. All right. Then I'll just delete this para hindi na siya mag-run. Then I'm going to run everything again kasama yung set that seed. Okay. And of course, we'll have the same values as for y kasi we have the same values as x. We have the same values as u. Okay. And if we're just adding them, class, then we have the same values. All right. So I'm going now to mag-model. I-plot muna natin, class. No? Control Alt I. Okay. Let's plot. So i-plot natin si x tapos si y. And let's see. Okay. What do you notice about the plot of x and y, class? Linear ba siya? Paki-comment please. I hope you got this. Plinat ko lang, class. Plot x and your y. Do they display a linear relationship? Yes, thank you. Thank you, Quina. Quina, please share your answer to everyone. Yeah, thank you. So, yes, correct. Thank you, Joseph. Thank you, Abigail. Thank you. So, not linear siya, no? It's more quadratic. Well, we were expecting this kasi sabi natin si y is a function of the square of x, right? Ito lang linear dyan, no? And this one, normally distributed naman yun na random numbers, so okay lang yan, no? Pero itong x squared kasi. All right? So in fact, if you get the Okay, sige. So let me just introduce to you now, how do we generate a linear model, an OLS, ordinary least squares model. So let's create a model called mod. Let's name it mod S. Nagkakaproblema tong ano ko. Let's call it mod S. Model simple. You may name it any way you want. Alt minus. All right. Now, in order to this is what's very good with R. It's very easy to run a regression model here. Okay. Ang function na gagamitin dyan is LM. Okay. So LM means linear model. So if you're running a regression model, just use LM, and then you identify ano ba yung dependent variable natin dito. Ang dependent variable natin is your y, okay? And you want to regress your y, you use shift, backtick, yan, tilde. That tilde class is nasa upper left, no? Above the backtick character. Regress y on x. So ganun lang kasimple class, no? Ganun lang kasimple. Okay. Regress y on x, and then let's run this. Let's see what will happen. Let's see what will happen if we use the LM function, and we're going to regress. We would like to model y, making use of our variable x. So let's run this. Run natin. And when you run it, class, what happened? What do you see in your environment window? What do you see in your environment window? Anyone, please? What are the objects that you see in your environment window? Class. Okay, can you see this one, class? Mod S. Mod S. And then notice now, there are now two compartments in your environment window. One is values, okay? So this one, and another one is data. So we have here, all the vectors class will be found under values, and all the other data structure types like list, like data frame, etc., which we're going to meet next time. No? We will be able to see that in our data. Okay, so what's this? If you recall, I mentioned a while ago, and I hope you have watched the video again. I hope I don't sound like a broken record, because in the video you'll meet this, no? The list object, the list data structure. A list can contain different types of data structure. It can contain a vector, it can contain a data frame, it can contain another list. So this is quite flexible, no, yung list natin. And if I click this class, okay, so this is what appears here. Okay, I'll click this one, class, this one instead. Itong magnifying glass icon, and then there you go. You can find here, ito yung mga ano, class. Ito yung mga laman ng mod S. We're going to study this in greater detail as we go along. So, all right. I just want to point out here, class, that okay, number one, there's no linear relationship between your x between your x and y. No? In fact, when we plotted this, we said that we can see here a quadratic relationship. So what did I do here? I was regressing y on x. Unfortunately, ang problem nito, class, is that y is not linearly related with your x, no? Diba? Tama, class? Okay. In fact, Okay, so let's just do this. If we plot class, let me just show you now. If we plot mod S, okay, tingnan nyo what happened, class. Remember, mod S is a list. It's an object. It's the object that pertains to your linear model where Y is regressed on X. Take a look at this, class. Now, it generated several plots. Okay, so if I go to the first one, take a look at this, class. So were you able to generate this plot? Actually, 5 plots to, no? 4 lang yung default na pinapakita. Okay, what do you notice about this? You have a plot of your fitted values, your predicted values, this one, and your residuals. So plinat nito, class, yung difference between your actual versus residual, actual versus forecasted, kasi the difference between your actual and your forecasted is your residual, diba? And then plinat on the y and the x-axis is the fitted value. So what do you notice about how your residuals behave? Comment, please, class. Any comment? How does your residual behave? In relation, class, to what we said a while ago, diba, one of the important assumptions of classical linear regression is that homogeneity of residuals. Okay, dapat yung residuals natin, class, dapat constant variance yan. Here, class, you don't see a constant variance. Okay? You don't see a constant variance. So dapat kasi kung constant variance, nag-randomly nag-spread out lang siya dito. Okay, here it has a pattern. So which means, class, that our model was not able to capture the movement, this movement. Okay? And then here you can see some numbers, 240, 35, 6. These are what we call, these are outliers. No? So dinefine na sa atin ng model natin yung outliers. Okay. Okay, let me just end, class, in, so what can we conclude out of that? What can we conclude out of what we did a while ago? Kasi we were trying to establish a relationship between y and x, making use of a linear relationship. No? In fact, ang sinasabi ni okay, if I add here, for example, so i-ano ko to, class, sorry. Ang bilis ng oras. Plot mod S plot mod S, class. Okay? And then, kasi 5 yan eh. I'll just choose which is equal to 1. Yung first one, the one that yung residuals versus fitted. And then I'm going to include a line, AB line, okay? Sasama ko sa AB line, class, sa mod S, and I'll color it red. Okay, sorry if I'm introducing other codes now, no? So what am I doing here? Okay, in case you Control C, so i-chat ko to. Okay, so what am I doing here? I'm plotting again, class, yung model S. Di ba sabi natin si model S, yung regression output yan, there are actually 5 plots that you can generate out of that, residual plots. Kunin ko lang yung number 1. No? And then I'm going to plot the regression line. Okay, ano ba yung regression line nitong model S natin? And I'm going to color it red. Okay, so let's run this, class, and see what happens. I'm going to highlight this and then Control Enter. Right, tingnan nyo, class. Okay, so okay, sorry, maling ginawa ko, no? Kasi dito prinat ko yung regression line, tapos yung residuals. I stand corrected, class. Dapat ang ipa-plot ko, apologies, no? Dapat yung ipa-plot ko yung relationship nila. Sorry, ah. So plot y and x, no? Sorry about that. Plot natin si y and x. Tapos ang gawin natin color is equal to, okay, still blue. Okay, ito yung pair na gusto kong gawin, class. Not this one. Not this one, class, but this one. Chat ko to para mabilis kasi almost time na. All right. So if you run this, class, I just want to point out, class, ano nangyari? Control Enter. Take a look at our data. Okay. Ito yung data natin, di ba? Tapos ito yung regression line natin. What do you notice, class? Ang daming errors, oh? Ang lalaki ng errors. Ang lalaki ng residuals. Di ba? Okay? Konti lang yung points na nasa line. Eh. The rest are all outside of the line. I mean, itong mga residuals to. For example, this one and this one, yan ang residual niya. Okay? Why? Because we're trying to fit a model where the relationship is not linear. So pag ganyan, lastly, class, I just want to insert this. Pag ganyan, class, tapos mas i-discuss natin to next time. I just want to point out, class, pag ganyan, pag hindi linear relationship, it will call for a different type of model. Hindi siya linear. Dapat yan quadratic, no? Okay, so sige, ano na lang, no? I-ano ko na lang to. I'm going to create another model. I'll call it model Q. Okay, quadratic, alt minus. Tapos LM din siya. All right, LM. Tapos Y regressed on. Okay, so I'm going to explain this next time na lang. Pero isulit nyo na lang. X plus. Now, if we're going to also, if I'm going to use, kasi square, quadratic, di ba? So dapat yan, dapat kasama si x squared. So how do you include x squared? Explain ko lang to later on, class. So okay, I then x, big X, and then squared. Okay, explain ko lang ano ibig sabihin itong interaction variable na to. So interaction yan. All right, so if I run this, oops, ano nangyari? Small x ba to? Sorry. Small x yata to. Yan, dapat capital X. Run. There you go. So may model Q na tayo, class, no? May model Q. Tapos if I plot model Q, tingnan yung difference ito, class. Tingnan nyo, class, yung residuals, no? Tingnan yung residuals. So ito heteroscedastic yung residuals na to, no? Hindi siya homoscedastic. Because what I did was I modeled si Y kasi at saka si X, ang relationship nila is quadratic. So it does not make any sense to model X, to model Y and X using linear. And lastly, end ko na lang to, no? I-plot din natin to, class. However, I'm going to change this with Q. Okay? Tingnan nyo yung model na to, class. Pareho din sa taas, plot yung Y on X And then AB line natin, yung regression line natin, we're going to use model Q and not model S. If I run this, control, enter. Okay. So what do you see now? Okay. So merong error tayo dito, no? We will just discuss this next meeting kasi nagsabi siya na, okay, only using the first two of the three regression coefficients. All right, let me stop there, class. I'm sorry about this. So we're going to continue with this next time, okay? And then, yeah, sobra na ako sa time. All right, so thank you so much. Magpapacheck na attendance. Stop recording ko na. Okay.